Hello, everyone, and welcome to a new series from ElastiFlow, where we'll be diving into the latest academic research and breaking it down into digestible presentations. My name is James Mattei, a software engineer at ElastiFlow, and I'll be taking us through our first installment in the series. But before we start, I wanted to give a little background about why I wanted to start this series. One of my favorite parts of my PhD program was the weekly reading group or journal club in the lab. We'd all take turns presenting each week. More senior students could use this as an opportunity to present their own research, and junior students could choose a paper in their research area and present it to the group. This was a great exercise for aspiring researchers to improve in several key areas. First of all, both preparing a presentation and watching one about a complex topic gives you practice in understanding key concepts in areas you may be unfamiliar with. Leading Journal Club gives you a chance to practice public speaking and making sure you can properly explain complex ideas succinctly, a crucial skill for your eventual PhD defense, like you see there, or for persuading your team members to support your ideas and contributions. Lastly, and why I personally love Journal Club, these presentations can serve as inspiration for your own work or research, or at the very least, change how you go about your work for the better. All that being said, let's dive into the paper we'll be covering today. And that's called Machine Against the RAG, Jamming Retrieval-Augmented Generation with Blocker Documents. First of all, great title, by the way. And I was inspired by a recent episode of our Signal Over Noise podcast, where engineering manager Reggie Ross mentioned MCP servers as an attack vector for LLMs. And that reminded me of this paper, which explores how RAG systems can be susceptible to denial of service attacks if an attacker is capable of uploading their own documents into the corpus. But first, let's do a little background. Retrieval-Augmented Generation, or RAG, is a common LLM architecture to enable language models to provide more detailed responses to user queries by utilizing a specific set of data. A typical implementation involves chunking and embedding the dataset you want the LLM to use and saving the vector representations of the data. Then, when a user queries that system, there will be a semantic search across that dataset to pull relevant portions of the documents that are similar to the user question. Lastly, the LLM can use that fetched data to produce the final informed output. But how can a system like this be susceptible to denial of service attacks? When some of us would think of traditional denial of service or distributed denial of service attacks, we'd imagine this scenario. An adversary targets a specific system with loads of bogus requests and traffic, overwhelming that target's resources and causing it to be unresponsive to normal users. While you could still employ this same technique to an LLM system, flooding it with a bunch of queries to overwhelm its resources, the denial of service attack the authors of this paper propose is far more nefarious and difficult to detect. The authors propose a unique attack on RAG systems that block, or jam, as I'll refer to it, and they refer to it, the LLM, and preventing it from answering just a specific question, not the entire service itself. They demonstrate how an adversary can insert just a single document into the database designed to jam a specific target query. This technique takes advantage of the LLM's internal safety mechanisms, tricking the LLM into suspecting that the user query goes against content moderation guidelines, despite it being benign. All the attacker needs to produce this attack is query-only access to the target RAG system and the ability to upload a document. They do not need to know the embedding model that's used, the LLM model that's used, or the ability to edit any of the other documents in the database. It's pretty impressive. Now, some of you may be wondering, James, how likely is this to occur anyway? Would an adversary really be able to upload a document into my RAG database and corrupt the whole thing? The reality is that it's more common than you may initially think. RAG systems that pull any sort of public data, like, say, SEC filings or quarterly earnings report for financial research, could get blocked from pulling data about a particular company. Similarly, an insider in your own company could suppress bad reviews or interactions with customers or negative feedback from appearing when querying that RAG system. Jamming is particularly effective because the LLM refusing to answer is a relatively common behavior, unlike an explicitly incorrect response or the system not responding at all. This makes it much more difficult to identify when your RAG system has been compromised, as obviously incorrect answers can be more easily detected. So, what is the technique for crafting a blocker document to disrupt a target RAG system? The authors outlined 3 different approaches to do this, including using another LLM to create the document for you, which I found amusing. But for time purposes, I'm going to focus on the most technically unique approach. Their algorithm involves iteratively replacing tokens in candidate documents to maximize the embedding similarity between the RAG system's response and the adversary's target response. This process has 4 key steps that are repeated. First, you select a random token in your document to replace. A token is essentially just a word or a part of a word. Then you create several candidate documents by replacing that token with new random tokens in the vocabulary. Then you sequentially upload your candidate documents to the database and query the RAG system with each one and capture the poisoned responses back. And lastly, you find the candidate document and response that creates the poisoned response most similar to the desired target response. These steps are repeated until the final document that returns the desired response is created. This method allows an attacker to generate a document only by querying the system and uploading documents. They do not need to know any of the underlying architecture or LLM models used in the RAG system. The authors tested their attack on several open source and proprietary models, including Llama 3.1 70B, 405B, Mistral 7B, GPT-4o, Gemini 1.5 Pro and Flash, and Claude 3.5, Haiku, and Sonnet. They found their technique has success across all of these different models in their setup to varying degrees. And interestingly, models with a higher safety score correlated with a higher vulnerability to jamming attacks. Additionally, blocker documents created with one target model, say for Gemini, could not then be used to successfully jam a different LLM, say OpenAI's. This indicates subtle differences in how each model evaluates the safety of the content. There are a variety of other nuanced findings that the authors do an excellent job of explaining in their full paper, and I encourage you all to check it out if you're interested. And the link to the paper will be in the description and at the end of the presentation. So, as an aspiring RAG system designer, what can we do to help protect ourselves from this type of attack? The authors investigate several approaches, but the most promising was to utilize something called perplexity scoring. Perplexity is a method for measuring the naturalness of text that is frequently used to identify potentially malicious texts or an AI-generated text. Here's a formula for calculating it for those curious, but essentially this calculates a score, a numerical representation of how unnatural a body of text X of length N is. You can use this formula to calculate the perplexity scores of trusted texts and then compare any new texts to this benchmark. Texts that score too high can reasonably be considered malicious. So by periodically computing the perplexity scores of documents in your RAG database, you can flag any potentially suspicious documents for further analysis. This paper was really well written and contained a lot of interesting information about potential attacks on LLM systems, their defenses, and much more detail about their experimental setup than I was able to highlight in this presentation. If you found any of what we talked about today interesting or have a question, please email me or post a comment on whichever platform you watch this on, and give the paper a read yourself. Thanks for watching.